and hello everyone. My name is Dan Kirkwood, Solutions Engineer based out of Sydney in Australia, and I'm really excited to be talking with you over the next kind of 15 minutes about Consul. Here is what we're going to be covering, but what I really want to get to is the why. Why do we care about visualizing application elements? And to understand that, I want to look at application architecture and kind of how they've evolved over time. Here we have the V1 of the HashiCorp application. This app is on bare metal compute. Users connect to this server and get everything they need. So this is relatively simple to own and maintain, but we have a challenge. As more and more users connect to this application, I can add more CPU, add more RAM, upgrade the server, but there's an upper limit on how far I can go with that. I've also got a bit of a risk here, right? If I lose this server, I've now got a lot of very unhappy users. So for V2 of my application, I now virtualize, and I now have multiple VMs that serve the same application. I've now also got multiple places to connect, which is a problem that I solve with a load balancer. So now my users connect to one point, my load balancer spreads those connections over instances of my application. I've probably got some kind of shared data tier as well. There are two groups, I guess, that are, even though this looks good, my users are happy and it's relatively simple, there are two groups that aren't really happy with this architecture. One is the business. This application is fast becoming the core of HashiCorp, our main offering. We also have hundreds of competitors who are developing similar solutions every day. So the business would like us to move faster on how we innovate with this application so we can get new features out to our end users. The other group who aren't really happy with this are developers, because as a developer, if I want to make just a small improvement to the user experience of this application, I have to jump into the monolith and try and work out where that change needs to take place among all of the code that's part of this app. The other challenge I have is if I want to deploy this application, that's a big process to deliver that code actually onto these virtual machines. And that means that I end up doing deploys maybe only once every 3 months, which the business really doesn't like. So we move to V3 of the application, which is built on a microservices architecture. I now have certain discrete elements of my app that are broken out. I've got other, sort of back-end services that I can connect to. And I can now have dedicated teams who work on iterating these particular critical functions. So now the business is really happy because we can move faster. Developers are happy because they only have to worry about one discrete chunk of code. They can iterate over that code without worrying about the rest of the app, as long as they maintain some compatibility through APIs. But this brings a whole new challenge for anyone that cares about how this app runs in production. There's a whole lot of potential complexity here, and that complexity grows as the number of services grows as well. And to sort of understand that complexity, I want to think about this application architecture. So this is a really nice kind of snapshot, a point in time view of the ideal state of my app. But the question that I would ask here is this actually what I have running in production? Okay. The other thing I would ask is that, we have a lot of lines here that now represent network connections. And if we think about networking, how do these different application elements actually connect? How do I make sure that a dependent element is aware of these new other dynamic elements when they scale up, when they scale down, when someone does a new release? Am I going to build kind of complex network logic into my application to be able to take care of that? Probably not. And I've seen multiple solutions here. Maybe you maintain a spreadsheet of which services you've got, how many instances there are, which IP addresses you've got, and then you SSH into each service and change a configuration file. Something that's quite slow to do and error prone and scales very dangerously as my services grow up. I could also insert a load balancer in between all of these elements. But again, I've then got a linear relationship between the amount of load balancers that I've got and the amount of services that I've got, and they become a big burden for someone to manage. So what can we do about this problem? And to answer that, I'm going to jump straight into Consul. Here is my application as it exists as part of the Consul service registry. So here we have a few of the application elements, my front end, the checkout, recommendations, and payments. And you might say, okay, well, that's nice, but what's good about this? The good thing about this is not a point-in-time snapshot of this architecture. This is a live view into all of those application elements. So for instance, I could look at the checkout, and this little green tick says that not only is this service registered, but I also have health checks that are operating against this service so that I can make sure that it's actually able to take traffic. Okay, so I'm doing a little HTTP check on a particular path for this application element. And just to show you, how live this is, if I was to kill the checkout service, I can see straight away that that's reflected within my service registry. Now, this is really useful for me as a person because I can tell very quickly what's healthy and what's not. This is also really useful for my applications because my front end can ask Consul, hey, where are the recommendation services? Which ones are healthy? Which ones can I use? Consul can return back all of the instances, or it could return back random instances of the recommendation service. And suddenly I'm sort of load balancing. I'm spreading my connections from the front end through to the recommendations service. And I've kind of solved this little problem of, which of my elements are where and are they actually able to take traffic? Okay, so that's the very first use case with Consul that we just looked at quickly there. There are many other use cases which we're not really going to have a lot of time to dive into today. I'll show you where you can find out more about them right at the end of this session. The one thing that I want to point out is that all of these use cases and everything that I show today is designed to work consistently, no matter your choice of platform for your applications. Okay, so you could be running bare metal on-prem, VMware. You could be in a major cloud, in a minor cloud. You could have different deployment patterns. Some applications could be on VMs, others could be in containers, some could be part of a container orchestration system. Consul is indifferent. Consul aims to work consistently across all of those different choices of platform. And it's really the only tool that I've seen that really does this effectively at scale. So to come back to our architecture, okay, so we now have a nice way of showing the application elements, but there's some information missing. Let's bring this back. There's some information missing from this kind of list of available services. And that is this nice view of relationships. So my architecture diagram draws out which services should be talking to other services. The front end should talk to checkout. Checkout should talk to the database, but the front end shouldn't be talking to the database directly. Now, notice I say should and shouldn't. This is, again, an ideal state. And I would ask the question here is this what you have in production today? And it can be really hard to prove, right? And you could think of maybe potential tools to solve this. Maybe I'm going to put firewalls everywhere to solve this problem. You get that scalability problem. Maybe my cloud provider says, hey, give each of these elements an identity, and then you can do rules between different identities, and then you've got a nice scalable system. And the answer is, well, yes, maybe, but do all of these services, are they compatible with your identity service? And the second question I ask is, are all of these elements likely going to be in one single cloud? And I would say increasingly, the answer is no, they are not. So we've got this problem, right, of how do we know if this application mapping is accurate in real time? And the answer to that problem is to look at a service mesh. Very quickly, what does a service mesh mean for Consul? Here we have two of our application elements, front end and payments. We have our Consul control plane service, which is running. These applications are registering with Consul just as before. However, now I've configured Consul to also manage a data plane element for my architecture. So Consul is going to deploy and manage a proxy, which in this case, this icon is Envoy. It has the most features for integrating with Consul, but you can bring your own proxy. Now, even though we're spinning up these data plane elements next to applications, it doesn't mean that your management overhead increases. There is no operations person that is going to be logging directly into this proxy to make configuration changes. Consul manages the full life cycle of that proxy and gives it all of the configuration that it needs to work with your application. Our applications then don't communicate directly. They send their traffic into the proxy, and the proxy then does a few things for me. First, it's going to do authentication. So the proxies have certificates that are managed by the Consul control plane. And this means they can do mutual TLS for authentication of your service mesh elements. Now, this is really nice because I now know, yes, there is an instance of the payments application, but are you a valid instance? Has someone put you in there maliciously? Have you been just hanging around for so long that your validity has expired? The proxies take care of all of those questions for me. This question of, are you a valid member of my application architecture? Once I've authenticated, there is then also a layer of authorization. So even though these two things can connect, is that something that I want? Should the front end be talking to the payments service? In this case, the answer is yes, and the communication would flow. If the answer was no, for instance, if this was the database service, then that connection would be blocked by the proxy in the data plane. So let's take a look at this. Here we have the same application. It's now deployed into a service mesh. There are a few other elements in here that we'll get to, but here we have the front end, we have recommendations, checkout service. We also have a way of defining the relationships that were on my architecture diagram earlier. So using intentions, I can explicitly map out that, yes, the front end should talk to checkout, payments, recommendations, and the checkout should talk to Redis, but the front end should never be talking to Redis. And notice here this kind of rule mapping, I'm very abstracted away from traditional mechanisms of implementing network rules. I don't need to know the IP addresses of any of these services, because they're likely going to be very ephemeral anyway, right? If they're in the cloud, if they're in a container orchestration system, it's very hard for me to guess what those IP addresses are going to be. I don't need to know the ports of these particular services. All I need to know is the service itself, and Consul will enforce this rule wherever that service appears. It's a really nice, simple way of mapping those relationships. That then means at the service layer, we jump into recommendations here, we still have access to the health checks, all of the available instances. We can find out what are the current IP addresses of those instances if we want. We can see what are the relevant intentions to this particular service. But Consul will then also build out for me a really nice topology of my application. There's a few interesting things here. The first is that I can see for my recommendations service, it is receiving traffic from the front end, and it is forwarding traffic to Redis. Now, I'm not saying should there, right? I'm saying is. This is the live view of what are the authorized connections for my service mesh. I can see the health of those two services. And if I'm in a troubleshooting situation here, I can check, okay, is my configuration correct for my mesh? Are these things allowed to talk? From the point of view of security policy, make sure no one's made a configuration, check. Are my services healthy? Check. The last bit of information that I then get access to is metrics from my data plane element directly. The nice thing about this is I can, now that every connection is going through that Envoy proxy, I can start to see telemetry around all of that traffic that's passing through the proxy. So in this case, we are seeing the data rate, right? What is the rate of data coming into the recommendations service in gray? What is the rate of data going out of the recommendations service in red? This could also be connection count, right? This could also be error counts. If I'm getting, I want to look at 500 errors over time. And that means if I've noticing a problem within my application, I can really quickly come and get a top level view of what is healthy and what is not. And I'd get that through this first screen. I can then get that second level of data of, okay, am I allowing connections between these services? Can I get an at a glance view of some of the metrics, live metrics against the connections within my mesh? And then if I need more, I can actually link to another dashboard. So in this case, it's Grafana. Grafana is pulling from the same data source, which is Prometheus in this case. And I can get access to all of the custom metrics that I might want that are exposed by the Envoy proxy and being pulled into Prometheus. So I can go really quickly from that top level view into a detailed view with the idea that my mean time to resolution drops from something that is potentially days or hours down to something that might be minutes. So how do I actually configure this? There are two key parts to the configuration for observability, the level of observability that I've shown today. On the left-hand side, how you would configure your Consul server to turn this on. And I think of this as the sort of subscriber definition. So here I'm saying that I want to use Prometheus as the metrics provider. This is what we include support for out of the box today. You can bring custom data sources as well. And then I'm telling Consul, where does my particular metrics server live with a URL? So that's for the kind of subscriber information. On the right-hand side, I've got configuration that applies against my application. So this is a deployment spec for my app within Kubernetes. Here we can see it's from my payments application, and I've got a few annotations here. First, I'm saying connect inject is true. This means, yes, I want this microservice to be part of my service mesh. Please inject the Envoy proxy. I'm then telling Consul, okay, what service is this? When this pod comes up, what should it register as? Payments. I'm then giving a protocol, and this is useful because I can start to do some nice kind of layer 7 routing. I can do path-based routing based on traffic coming through the mesh. I can also do something like a blue-green deploy or a canary deploy using metadata that I define through the annotations as well. So my version 1.1 and 1.2, I can configure how the Envoy proxy is going to route traffic depending on different versions of the same application element. The last bits of configuration I have here are what I'd call the publisher configuration. So here I'm saying, yes, I want Prometheus to be probing this pod. And here is the port that I'm going to turn on to allow the metrics to be exposed from the Envoy proxy. And that's it. So I hope I've shown you, three things that I really want to concentrate on for this snapshot. Number one is that you could use Consul just to show a catalog of, what are my application elements? Does my application in production match what my architecture looks like? And a wide range of use cases just for that sort of service catalog view of your application. Number two is the way of mapping, those relationships between your application elements, actually enforcing them can be done through Consul as well. And lastly, this idea of, how do I bring together the right data and metrics and relate them back to my service mesh definitions to very quickly expose, okay, here I have a problem. Where can I work out, which element is actually causing that problem? Which network connection is having an issue within my service mesh? So those are the three things that we looked at today. So I hope you enjoyed that. If you were interested in that and you want to know more, there's plenty of places to go. Number one, the HashiCorp Learn site has a lot of really good information. Learn.hashicorp.com. We have a track there specifically on Consul Service Mesh for Kubernetes with many different topics. One of those topics is layer 7 and observability with Consul. So I'd encourage you to check that out. Secondly, consul.io is the place to go if you want to know more about some of those other use cases for Consul and also kind of what's new and what's coming up for the Consul project. Lastly, our YouTube channel. So two things I think that you can get out of this channel is, number one, if you're looking at how do people actually run Kubernetes, not Kubernetes, run Consul at scale in their business, we have our customers who talk about how they use Consul. Secondly, if you're really interested in more around the configuration and deployment of these kind of features, we run things like community hours very regularly, and there are a few sessions on there related specifically to Consul and service mesh. With that, I want to say thank you for joining me. I hope you've enjoyed it.